Last example for chapter 10. Remember, this is our challenge. This is our fun. Let's see if we can count examples. We want to look at how many pi and sigma bonds are there in trinitrotoluene. Fun molecule. For those of you who don't know, we have trinitrotoluene. So TNT. We want to count the number of pi and sigma bonds, and we also want to look at the hybridization of each carbon in the benzene ring and the hybridization of one of the nitrogens. They're all the same. Okay. So I don't expect you to know what the benzene ring is. I will show it to you. I also don't expect you to be able to draw out trinitrotoluene and know what the structure is. Okay. So I would definitely give this to you, what I'm going to draw out on the exam. This here, the hexagon shape, this is when we put some double bonds in. This is the benzene ring. Toluene has a methyl group coming off of one of the carbons. Okay, methyl, methane, CH3. Then we have trinitro, so we have 3 nitro groups. Nitro groups are NO2. With the nitrogen being what's bonding to that carbon there. So this is a kind of a stick reduced Lewis structure. These are very, very common. This would be the most common representation of this molecule in an organic chemistry course. So what we want to do in order to determine our sigma and our pi bonds is we want to transfer this, we want to redraw this out, and we want to show each of the carbons. So wherever 2 lines intersect, there's going to be a carbon there. So in the first hexagon shape that I drew, we have 6 carbons there. At the end of the line also, there's going to be a carbon, so that's the methyl group, that is a carbon there. Then hydrogens typically in organic molecules are left off when we draw them. We assume that they're there. As chemists, we know they're there, but they're not that important to us most of the time, so we just leave them off. Okay, so for instance, on this carbon here, we're going to have to complete carbon's octet so that it has 4 bonds around it. Yep, so I'll show you this. So basic structure, we want to start by drawing out that hexagon shape. So we want carbons. By the way, one of the ways that you can tell if you're going to be a good organic chemist is how well you can draw a hexagon. Not really. But you get really good at drawing hexagons. So here are the 6 carbons. Then we have a 7th carbon right there going up top. So we have 7 carbons. Then we have double bonds, basically every other carbon. So we have a double bond there, skip 1, double bond, skip 1, and a double bond. Then we have this nitro group, NO2. This is known to have a single bond to one of the oxygens, double bond to the other. So we'd have nitrogen to oxygen and to oxygen. In addition to adding adding hydrogens to complete octets, we also need to add lone pairs of electrons. So on this oxygen here, we have 2 bonds. We need to add 2 pairs of electrons. The single bound to oxygen needs 3 pairs of electrons, which means it'll have a negative formal charge. This is a neutral molecule overall, so we need to match this negative formal charge, which we'll find out if you look at it and calculate it out. Nitrogen has a positive charge. So we need to add our other nitro groups. Once you have your nitro groups drawn out, then you want to add in your hydrogens. So typically we add the hydrogens to carbons. So any carbon that doesn't have a complete octet, we want to add enough hydrogens so that it has a complete octet. So the carbon up top here only has one bond. It wants 4. So we're going to add 3 hydrogens. This carbon here, the top of our hexagon, we have 1, 2, 3, 4 bonds. That one's good. This carbon here, 1, 2, 3, 4. That one's good. We have 1, 2, 3. We need to add a 4th. Carbon at the bottom, 1, 2, 3, 4. That one's good. This carbon, 1, 2, 3. We need to add a hydrogen. All of our octets have been completed by either adding lone pairs of electrons, as we did on the oxygens, and our carbons by adding hydrogens. Now we can answer our question of how many pi and sigma bonds there are. This does involve counting, and we have a fairly large molecule, so I recommend kind of putting a hash mark or highlighting each bond as you count it, so that in case you make it all the way around the molecule, you can really remember if you counted that bond or not. So sigma bonds are all of the first bonds, so essentially any line connecting atoms need to be counted. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. We have 21 sigma bonds. Pi bonds, the double bonds. We have 1, 2, 3 in our nitro groups, then 4, 5, 6. We have 6 pi bonds. We want to look at the hybridization of our carbons in our benzene ring and look at the hybridization of our nitrogens. They're all the same. So we have our orbitals that we can hybridize. Each carbon in our benzene ring is all actually the same. So this carbon here, we have 1, 2, 3 areas of electrons, so we need 3 orbitals. So we have sp2. So this is sp2 hybridized. The nitrogen, again, same hybridization. It has 1, 2, 3 areas. 1, 2, 3 orbitals, so sp2. Go ahead and try and determine the hybridization of this methane carbon here, the CH3 portion. This carbon here has 1, 2, 3, 4 areas of electrons, so we need 4 orbitals. We have the sp2, 3. We need all 3 of the p orbitals, so this is sp3 hybridized.